take a look at this problem. We got 6x squared minus 12x plus 1 equal to 0. And we'll solve this using the quadratic formula. Well, the first part is you have to have 0 on one side, which we do. So let's identify our a, b, and c. A is a number that's in front of our x squared, which is 6. B is a number that's in front of our x, which is negative 12. And c is our number at the end, which is 1. We got x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And we'll go through and replace my variables with sets of parentheses. Everything else remains exactly the same. This is a really good thing to do if you mess up on signs. Okay. Now b we said was negative 12. So negative 12, negative 12. A we said was 6. So I put the 6's in, and c is 1. So we just plug in the appropriate number in the appropriate place. Negative negative gives us a positive 12. Plus or minus square root. Negative 12 squared is 144. Minus 4 times 6 times 1 is 24 over 12. Which gives us 12 plus or minus square root of 120 over 12. 120 looks like something I can simplify. Let's see, 120. It's divisible by 2, definitely. 2 times 60. 2's prime, so we circle it. 60 is 2 times 30. 2's prime, so we circle it. 30 is 2 times 15. 2's prime, so we circle it. And 15 is 3 times 5. And both of those are primes, so we circle it. So we got 12 plus or minus square root. We got 3 2's. We got a 3, and we got a 5 over 12. Now remember, the square root, we're looking for a pair of somethings. So here's a pair of 2's. They're going to come out in front as a single 2. So we got 12 plus or minus 2 square root. 2 times 3 is 6 times 5 is 30 over 12. Should be called the 3-number rule, but anytime you can divide this number, and this number by the same number, do so. And those are all divisible by 2. So 12 divided by 2 is 6, plus or minus 2 divided by 2 is 1. Square root of 30 over 12 divided by 2 is 6, which gives us 6 plus or minus square root of 30 over 6. Now you can't simplify those 6's because it has to be these 3 numbers for you to be able to reduce when using quadratic formula. So that's our answer.